Alright everyone, I'd like for you to take a look at the system of equations here, and I'd like for you to stop, pause, and just think for a moment which of the methods we learned last week you would use to solve this system. Okay, so I'm going to give you a few minutes to go ahead and write down your answer. You can choose any method of your choice. As we discussed last week, all these methods should give you the exact same answer. So go ahead and select your method. I'll give you a few minutes. Be prepared to share your thoughts with a partner. I'd like for you guys to discuss why you chose the method that you chose and maybe compare your answers. We'll get back together as a class to discuss this as a whole. Okay, quick pause here for teachers. I just wanted to let you in on what was going to be happening during this time. During this time, the students are going to be participating in a Think, Pair, Share activity in which they are going to be given a few minutes, no more than 5, to work on this system of equations and solve it using the method of their choice. They will pair up with a partner next to them to discuss why they chose the method that they chose. Each of them will be encouraged to make sure they pitch in on the conversation. And then we'll get together as a whole in which students will volunteer to express their thoughts and their thinking process as to why they chose the methods that they chose. Through this discussion, I'm sure I would get some students that maybe didn't get the correct answer or had questions on how to do either of the methods, which is why now the next thing I would be doing is explaining how to use both methods that we have learned in the past to solve the system before introducing the third method. Okay, all right, and now back to our regularly scheduled programming. Here we go. Okay, so as everyone mentioned, as most of you mentioned, graphing is a method you can use to solve this system of equations. And if you look at your graphic organizer, we can use this as a clue to tell us what needs to be done in order to use it. We need to make sure that both equations be written in the y equals mx plus b form and the slope-intercept form. Taking a look at the system, we notice that actually neither of the two is written in this format. So let's first do that. Let's take our first equation and start writing into the correct form that we need it to be in. Okay, again, if you remember from last week, our goal is to get y by itself. So in order to do that, we have to subtract 2x from both sides. Take away from this side, we end up with 5y equals negative 2x plus 3. And we can't combine negative 2x and 3 because they do not have like terms, which is why we write it this way. And now we divide both sides by 5 to get y by itself. And finally, you end up with y equals negative 2 over 5x plus 3 over 5. You end up with this as your final form, matching the slope-intercept form here. Alright, so we got that one done. We need to take a look at the second equation. So let's go ahead and take that one and put it in the correct form. So we started off with negative 2x minus y equals 5. We add 2x on both sides to get y by itself. You end up with negative y equals 2x. I'm sorry, this should have been an x. So negative y equals 2x plus 5. And the negative y means we have a negative 1 in front of it, so we go ahead and divide everything by negative 1 to get rid of the negative there. And you finally end up with y equals negative 2x. It can be written as negative 2x or negative 2x over 1. Either way is acceptable. They mean the same thing. And then finally minus 5. Okay, so we have our second equation in slope-intercept form. And just because we have negative doesn't mean it's not in slope-intercept form. It definitely is still in slope-intercept form, so we don't have to worry about that, as we had discussed last week. So let's go ahead and graph these two equations. So start off with the first one. Our y-intercept is here, 3 over 5. So we need to graph our y-intercept first, as this picture tells us here. So 3 over 5, it's really difficult to get it exact. I'm going to go ahead and write my point right here, right before 1. Almost 1, but not yet 1. And then our slope is negative 2 over 5. So we're going to go down 2, 1, 2, and over 5. 1, 2, 3, 4, 5. Again, it's very difficult to get it exact. So I'm going to go ahead and put my point there. And now let's go ahead and connect our 2 points to get our line. So we'll say something maybe like that. And like I said, it's hard to get 1, 2, 3. Hard to get it exact, but we'll try our best. Okay. Now looking at our second equation, our y-intercept is negative 5. Sorry. Okay, so our y-intercept is negative 5, so we'll start there. 1, 2, 3, 4, 5. Down here, our slope is negative 2 over 1. So we're going to go down 2, 1, 2, and over 1. Right about there. And I was just counting to make sure those are correct. So let's go ahead and connect our points to get our line here. And it's somewhere, we'll just say something like that. Okay. Recall from our graphic organizer what we've been doing last week, the solution when we are using the graphing method is wherever the lines meet is a solution. So let's go ahead and take a look at what we graphed and look for where the lines meet. And that point is right about here. Right there. Okay, let's come up with our ordered pair solution. Our x looks like it's about negative 3.5, which we can also write as negative 7 over 2, comma, and y seems to be at 2. Okay, and I know from doing this problem before that this is the correct answer. However, if you notice, we ran into the problem of not being exact when it comes to the graphing part. This should be a clue that maybe graphing is not the best method to use for this system, only because you're dealing with fractions like the ones in here, which make it really difficult to be exact with graphing. This is why I would recommend using a graphing calculator, as we did last week, just to make sure our graph is correct. Again, so I feel as if this system of equations could be done, solved using a different method, a little easier. And as some of you mentioned, we have the substitution method, and most of you actually selected this method. Alright, in the substitution method, if you recall, we need to start off by singling out x or y and creating a blob. Rachel mentioned she used the y in this equation down here because y didn't have a coefficient in front of it, making it a little easier to single out. And I agree, so we'll use that one. But honestly, you could have singled out any of your variables in either of the equations. Let's go with Rachel's example. So negative 2x minus y equals 5. We're trying to get y by itself, and just like we did with the previous method, we're adding 2x to both sides. We end up with negative y equals 2x plus 5. We divide by negative 1 on both sides, and you end up finally with y equals negative 2x minus 5. And we have our blob. So this is the blob we discussed last week. That is what we will be using to plug into our other equation. Here, we can just stick that blob right in there, and it should give us our answer, our solution. So let's go ahead and do that one. Let's take 2x plus 5y. And again, instead of writing this y, we could just stick the blob in there, so let's do that. Let's set ourselves up a nice space to put our blob in. Since we have more than one term, we'll put it in the parentheses to make sure we do our calculations correct. And we can literally take what we have in our blob here and just stick it right in there. And continue with our equation equals 5. So now we're left with 2x, and we're going to use the FOIL method. We find out that it's 2x minus 10x. 5 times negative 5 is minus 25 equals Oh, I'm sorry, this should have been a 3. Equals 3. Okay, I copied it wrong. Then we are going to combine like terms. We can combine these two here, so we end up with negative 8x minus 25 equals 3. Moving 25 to the other side to get x by itself, because that's what we're trying to solve for right now. We end up with negative 8x equals 28, divided by negative 8 on both sides will give us 8 equals negative 7 over 2. Nice. So now we have our x, and we can use our x to find our y. And we know what our y is. Our y was here, remember? So let's get that back in there. Let's get that back in there so we can help us remember what we were using for y. This is what we used, our blob. So let's use that equation to figure out what y is going to be now that we found x. Just plug it directly in there. Y equals negative 2, and again, instead of using x, we use this right here to plug into x. So let's do 2 times negative 7 over 2 minus 5. These cancel out. You end up with y equals 7 minus 5. And your final answer, y equals 2. Nice. And if you notice, the answers match. We have 7 over 2 here for our x and 2 for our y, just like we did in this answer. So you just solved the system using 2 different equations. We noticed that the first one didn't work out so well, the second one worked out a little better, but I'm going to introduce you to a third one, a third method you can keep in your pocket for whenever you're trying to solve these systems. And we can figure out whether or not it's easier for us. So let's take a look at our third method, elimination. We're going to use the elimination method to solve this system, and this is how it works. Taking a look at our graphic organizer again, we have to line them up, look for matching coefficients, and add or subtract to eliminate. What we mean by line up, we want to line up our variables and our solution, which, check, we have that going on. We want to look for matching coefficients, and we have that going on here, and then we can add or subtract to eliminate that coefficient. So looking at this here, the system, we can use addition, because when we do 2x plus negative 2, that's going to give us 0x. Basically, I'm eliminating it. Then we're left with 5 minus y equals 4y, which equals 8. Dividing by 4 on both sides, we find out that y equals 2. How easy was that? Super easy if you ask me. Easier than the other 2 methods for this system. And now we plug in this y into our previous, to our other equation to find out what x is. So all we have to do now is 2x plus 5y, which we found out was 2, equals 3. You end up with 2x plus 10 equals 3. We need to subtract from both sides. So let's do that. Minus 10, and we end up with 2x equals negative 7. Divided by 2x on both sides, by 2, on both sides. And finally, we end up with x equals negative 7 over 2. And we got it. Matching our other 2 methods. Nice job. So now we're going to go ahead and practice this a little more. And like I said, if you notice, this elimination method ended up being a lot easier for this system to use to solve it versus the other 2. And I guarantee you after some practice, we're going to continue to practice elimination. I guarantee you by the end of this week, you guys will be a lot better at this. You will be practically experts at recognizing when to use which method when you look at a system. All right, nice job, everybody.